If we get through with the lesson, then yes. But I think we're going to end up finishing it tomorrow. So this first part, we're going to look at these here, writing in interval notation. I realized this morning that this isn't directly in your notes because I need to go back and fix this and get this squared away so they actually do line up. Because this note sheet's been a little all over the place. But interval notation isn't anything new. Because when we talk about interval notation, we're talking about using parentheses and brackets. Because parentheses, if we use parentheses, it is our not equal to. That number is not included. It goes all the way up to that number, but does not include that number. If we have parentheses, it means that it is going to be equal to that number or it is included. Because if we have an equal sign, then it's included. So these here aren't specifically in the notes, but if you want to write them on the back of the note sheet, you can. Because I'll need to fix that for next time. Now, the first one we have from -2 to -3. So if we drew this on a number line, we would have -2 and 3 as our two endpoints, because this is one of our bounded intervals. At -2, we would have a circle, and at 3, we'd have a circle. And would these circles be filled in or open? Why would we say filled in or opened? Because are they equal? Is x equal to -2? Because what is equal to? We have -2 is less than or equal to x, is less than or equal to. Since it is equal to, both of these would be filled in. And if x is in the middle, we shade in the middle. So this, if we drew this on a number line, we'd have closed circles at -2 and 3, and we'd shade in the middle. If we talk about in interval notation, our two endpoints would be -2 and 3. So we'd have -2, 3. And if they are included, we use brackets. So this is our interval notation here. And this is a graphical representation of it. Questions on this here? Now, if we look at the next one, x is greater than -1. So this here, whenever we have exactly one number going off into a direction in just x, that means infinity or negative infinity is going to be included. Now, sometimes it's going to be easier to actually draw the graph of it to be able to see it. And since it gave us an inequality, it gave us one of our key numbers, our key points, which is -1. And we'll have a circle here. Now the question is it going to be opened or closed? Open, because its x is just greater than, it's not equal to. Now would we shade to the left or to the right? So which one's bigger, x or -1? X. So all the numbers should be bigger than. So which direction are they bigger, to the right of it or to the left? Mm-hmm. Okay. Now, so we have the graph, yes? So the inequality, or our interval notation, so we'd have -1. Is it going to infinity or negative infinity? Which direction are we going? Are we going in the positive direction or negative? Because if we're going to the right, we're going to the positive. So that means it's going to be from 1 to infinity. Was -1 included? Did we fill the circle in? So it would be a parenthesis, because if we fill it in, it's a bracket. If it's equal to, we use bracket. If it's not equal to, we use parentheses. So what's going to be next to infinity? Parentheses or brackets? Because infinity or negative infinity never gets a bracket. It's always going to be a parenthesis. All right. Let's look at the next one. Now this one here, they did give us a number line. Yes? So let's write the interval notation. Do we have two endpoints or one endpoint going off in one direction or the other? Two endpoints. What are our two endpoints? -3 and 4. So we can put the smaller one on the left, so -3, comma, 4. No. When I was redoing the note sheets and making it 2 and trying to get it better adjusted, apparently this slide got thrown out at some point. So any questions on how we set this up so far? Because whenever we have two endpoints, we're going to put those down for interval notation. We always put the smallest number first, bigger number second. Smaller number on the left, bigger number on the right. Now, is -3 included? Yes, it's filled in, so we would have a bracket. Bracket means it's included, parenthesis is not. Is 4 included? Because if it's open, it's a parenthesis. If it's closed, it's a bracket. No. Open is parenthesis. Bracket is included. Bracket is closed. Open is parenthesis. And I'd have to look that one out, spell parenthesis up too. Let's look at the next one. Do we have two endpoints? No, because whenever we especially shade all the way to the arrow and include the arrow, it's going to continue in that direction for forever. So one of our endpoints is 3. The other is what? Infinity. Would it be positive or negative?
No, negative.
Negative. It's going in the negative direction, yes? So which one would we list first? Negative. So which one's smaller going to be? Negative infinity or 3? Because it's a massive negative number, so it's the smaller than 3, so it would go first. Which one has the bracket? Because, yeah, so bracket's closed for 3. Infinity and negative infinity will never get a bracket, because no matter how big negative infinity is, we can always find one bigger. We can never get to it. So if infinity, if it goes in one direction or the other, infinity will always get the parenthesis. Then we have to check for the other side. Yes? I think it'll be different because of the lunch change. I do not. You can call Denny, or I can call Denny. So this here is not in your notes, but it's going to be definitely good to take, write this on the back. So we're looking at set builder notation next. So looking at this here, now, again, we're going to look at the key parts and then we're going to do a few of these, because once we see these and how these work, there's not as much to them or as complicated as they look. So when we look at this here, writing in set builder, the first thing that we will always have is 2 braces. So guys, you'll definitely need to write this down, especially on the back. Set builder notation will always have braces to start and end it. So you can write this, and I'm going to explain it as we go, or you can write as I explain it. Set builder notation. So this is kind of the way set builder notation, so this whole piece here in the center, this whole thing, this whole statement here is set builder notation. It will always start and end with braces. Now the first part here, this X is describing what type of numbers we're talking about. So when we talked about yesterday, the different types of numbers, natural, whole numbers, integers, rational, irrational, real numbers, that's what it's talking about. And unless it specifically tells us what number types we're talking about, if it doesn't tell us, it's all real numbers. If it doesn't specifically tell us integers, whole numbers, natural numbers, we're talking about all real numbers. Which, if it's just talking about real numbers, all we got to do is put an X. Because it's just understood if it's brace X bar, it's the set of all real numbers. So we don't have to specify. All right? The other thing that it will always have is after that, it will have a bar, which is understood to be such that. So if we see a setup like this, what it's saying, so brace the set of all real numbers such that this part here describes what we have. So what this is saying is that the set of all real numbers such that X is less than B, whatever B is. So if B was 4, that means the set of all real numbers such that X is less than 4. So the first part is telling what types of numbers that we have, such that describes it. Well, you just usually use X as the variable. If it says, or it's talking about Y for all values of Y, and then describes it, then we would use Y. But normally we just use X. If it tells us, because most of the time it'll tell us what it is. If it doesn't, we're just using real numbers. So if it doesn't specifically specify, we're defaulting to all real numbers. Especially if it's on inequality or interval notation, it's understood to be all real numbers. And if it doesn't say, we're just going to use real numbers. Now, this next part, this is in your note sheet. So this here, it should be closer to the middle of the packet. So this here, I want to start off with doing these here. So the first thing we're going to do with any of these here is to set up our different parts. So when we look at the first one, the set of all integers greater than 5. It told us what kind of numbers we're working with here, yes? Because what type of numbers are we working with? Yeah. Integers, the set of all integers, yes? And the symbol that went along with this yesterday was our Z. It's a shorthand way to write integers, so we don't have to actually write out integers every single time. And what kind of integers are we working with? Greater than 5. So they told us the type, yes, integers, and they described it greater than 5. Now, whenever we do this here, we'll normally need inequalities. We can't use intervals. So like the second one, B, we can't leave it as an interval. We have to write it as an inequality. So if we're saying greater than 5, we'd say what? X is greater than. Questions on any of this here? Anything we don't understand so far? Okay. So we identified the types of numbers, integers. That's what it told us, yes? Which is our Z. It told us also that they're greater than 5. So we're write the inequality, X is greater than 5. Yes? Okay. Now we're going to actually write it in set builder notation. The thing that starts every part of set builder notation is a brace. It's just how they work for a brace. So brackets is kind of a big C. This here is a brace. So you can do an S and then a backwards S. X. So a brace and then X. Now if this had been all real numbers, we can draw the bar. But since it's not asking or telling us that we're talking about the set of all real numbers, we're saying X is a what? Integer. Now there's a symbol we can use for this here to make it easier to work with. And it looks like a little e. And what this stands for in mathematics, especially in set builder notation, is element. So we're saying X is an element of what? What's our number type? Integers. So here, X is an element of the integers. X is an integer, because that's the number type we're using. Such that, because we described the number types, we described what type of numbers, yes? And what did it tell us about these numbers? They're all what? X is an element of the integers. Questions on this so far? So, any questions? Now, there is another way we can write this, because probably at some point you're going to do these and check what the book says. The book is going to give you something different. And it's not that this is wrong and that one's right or that one's wrong and this is right. This is I would say, a more mathematical, pure math way to write it. So if you go into more pure mathematics, higher level, they're going to default to this more than what the textbook has. Now, what the textbook has is going to tell you brace X bar. It's going to have this every single time. The set of all real numbers such that, we said what? It is an integer, yes? X is an integer. And what? And X is greater than 5. Same exact thing, except we really just wrote it out. Both of these are correct. One of these is just a condensed version of the other, but both of them do work. Personally, I like the one on the left, yes, because it's a little bit more condensed, but they do the same thing, yeah. We'll finish it tomorrow. The other one says the same thing, but it's just a little bit longer and a little, I would say, not as complex or much to it. Any questions on any of this here? We're going to fall asleep?
Actually, I did.
Yeah.
The little E, like,
Mm-hmm.
that.
Mm-hmm. Yeah. I mean, if you don't write it exactly like that, that's fine. Because what that's saying, it's an element of this here. As we're going to keep going, I think we still have a lot more time. Yeah, 12-16. When's the scrimmage? Friday is, where is it at? Possibly, actually, no. Unfortunately, no. Because I won't be here Friday. No. Because I think, as y'all have heard, I think possibly through the grapevine, maybe not, I ref volleyball. And they've scheduled me to ref 4 games Friday. The first one starts at noon. The last one starts at 6. JVU. we'll have to get to JV by 11. We have to get there an hour early to make sure dressed out and then go through all warm-up procedures. Yes. Yeah, I'll make more doing that in a day than I would here.
Really?
Yeah.
You get paid salary.
Do full time.
Because the linesmen make about $70 to $75 a game. And the refs make even more than that. Yep. 75. Let's look at this next one here. So it's an inequality, not inequality, it's an interval. So we have these two intervals. So we'll need to turn it into an inequality, and then we can write our statement. Now, one of the nice things is because this is an interval, it's understood that it's all real numbers. So we're going to use all real numbers for this here. Now, the first one we have is negative infinity to 1. Now, for writing an inequality, sometimes it's easier to actually just graph it so we can see it visually before we write the inequality. Now, the one main number that we do have here is negative 1. Now, at negative 1, is it open or closed? Open, because we have a parentheses. Now, from negative 1, is it going to the right or to the left? It's going to the left because it's going to So if we wrote it as an inequality, x would be what? X is less than negative 1. Or our other statement will also have negative 1. We'll have an open circle. Now, guys, the shading for this one here, are we going to go to the left or to the right?
To the right.
Because it's going to. So its inequality would be x is what? Because it's bigger, so it would be. So we've changed it from interval to inequality. Questions on how we switch from interval to inequality? Now, since we are dealing with all real numbers, so for our set builder notation, we're going to start with our brace x bar. Because unless it specifically states something other than the real numbers, we're going to default to that. And if it is the real numbers, we just have brace x bar. All real numbers such that, what's our description? This right here, yes? So we just fill it in. Yeah, we just copy it right down. If it had started with an inequality, if it told us, write x is less than negative 1 or x is greater than negative 1 as an inequal, as in set builder notation, we just fill it in. Questions on this here? Let's look at the next one. Negative infinity to negative 1 or 1 to infinity. So we need to rewrite these as inequalities. So if we rewrite these as inequalities, so this one here, if we drew it on the number line, so negative 1, would it be opened or closed? For this here. Closed, because brace would be closed. Now would we shade to the left or to the right? To the left. So our inequality would be x is what? Greater than, less than, greater than or equal to, or less than or equal to? Because since negative 1 is included, we do have the equal to. And since we're shading to the left of it, it would be less than. Or, if we look at the other one, So at 1, is it going to be open or closed?
No, yeah, open.
Because we have a parenthesis. Parenthesis means open. Now, will we shade to the right or to the left? So x is going to be what? Greater than 1, because we're going to the right of it. Yes. Oh, go on. Because all the values greater than 1, so infinity would be greater than 1. Anytime negative infinity or infinity is included in interval notation, it's not written in inequality. Because it's kind of that understood the fact that all the numbers bigger than 1, so it is going to positive infinity. All the numbers less than negative 1, it is heading to negative infinity. Now we can write it in set builder notation. So we have brace x. All right, you can draw an arrow. X bar. Because it didn't specify what type of numbers, and we're talking about an interval, it's going to be all real numbers. So we'll have brace x bar. Then we fill in our information. All right, we're going to look at the next one. If there's, or before we do that, are there any questions on the previous one, how we got to that? Because really, once we get the description, we're just filling it in. Now, if we look at the next one, it tells us what type of numbers, because the set of all integers except -4. So what type of numbers? Integers, which is our z. So except -4. So we can have any integer except for what? So what can x not be? What's a way that we can say not equals or not? So if something's equal to, we can do this. If it's not that, we put a line through it. So we can say what? X is not equal to? So if we write this here, we'd start with brace x. So one we're going to do first is the element, because we can say x is an element of the integers such that what? X is not equal to -4. Any questions on this here? All right. Let's look at this next one here. Writing subsets in set notation. Now, some of these will use intervals. Some of them will use inequalities, because we can use intervals or inequalities. Or we can just list them out. Now, if we listed all the whole numbers, 50 through 54, guys, focus up here. Well, the first whole number that we can list is 50. What's the next whole number? 51. Then, and lastly, because our whole numbers are just our counting numbers. So 50, 51, 52, 53, 54. We can list those easily. So we can go on and do that. Now, if it said list all the whole numbers greater than 50, well, and then we can do ... as we talked about yesterday, because if it makes a pattern, we can use the ... to say it continues on with that. And if we don't put a number after it, it just continues on forever. But since it's just going to 54, the real numbers 0 through 4. Is that because real numbers 0 to 4, so we have 0, 1, 2, 3, 4, yes? Would a half be included? Yeah, a half is a real number. How about 1/3? 1/3 is rational, so it would be real. Or how about 0.124? 0.179? Is there any way we can actually list all of these here? No. So what we can do is say that 0 is less than x is less than 4. We can use an interval or an inequality. Or we can say an interval 0, comma 4. Either of these would work for writing this as a set. Questions on this here? Because realistically, the numbers between 0 and 4 is infinite, the amount of numbers we can get. Let alone between 0 and 4, just 0 and 1. There's any number between 0 and 1, so 1/2 is between 0 and 1, yes? 1/3 is between 0 and 1. 1/4 is between 0 and 1. 1/5. I can put every number that actually exists as 1 over that number, and it'll be between 0 and 1. We can do the same thing for 2 or 3 as the numerator. So really, realistically, there's an infinite number between 0 and 1, let alone 0 and 4. So there's no possible way for us to actually label or list all of them. So we have to use an interval or inequality. Negative 1,000 through 1,000, not 1,000, I did that again. Negative 100 to 100. Now with integers, we just have negative 100, negative 99, negative 98. We don't have anything between them. So we could actually list this out as negative 100, negative 99, negative 98. So we can use the ... but it does have an ending point. Where does it end at? Guys, let's focus in here. So we started at negative 100 and we went to... So really, at this point, the way we use the ... is that it's continuing from negative 97, negative 96, all the way to 100. Any questions on this one here? Yes. Let's focus in. I did a few. I'm not trying to cross. The main ones I've played are swimming, tennis, and then I've been playing hockey most recently. I'm all right. So we'll stop there. We'll finish this up tomorrow.